My name is Chris Olmsted. Today we're going to be talking about database modeling. First, I'd like to thank Codesmith, Genie, and Bractlet for sponsoring this talk. I think we're going to have a great time. So, database modeling. Here's today's agenda. First, we've successfully had an introduction. Then we're going to talk about database modeling, some key concepts in data modeling. We're going to do a quick recap, and then I'll take some questions. So, what is data modeling? Data modeling, database modeling, is the process of creating a visual representation of what data exists in a system, how it's stored, and what relationships exist between those data points. Basically, it is how are you making your data work for you in a shape that you can expect. Why do we bother? Well, because the data is the core of your business. Everything that you are doing relies on the quality of your data. So let's look at this image over here, right? We start at the bottom with your data model. This supports your systems and the rest of your data itself. Your systems, for example, how they integrate with one another, how your simple interfaces interact directly with your data itself, whether your data is redundant, keeping down your storage costs, things like that, and whether the data that you expect is compatible with the systems that you're already planning on using. All of this piece itself still is the support for your actual functionality. Your business, your app, whatever it is, relies on these that rely on your data model. So it's important to get right. Some key concepts in data modeling. We'll talk about the different types of data models. We'll talk about data modeling notation. And then we'll talk about normalization and denormalization, which is my favorite part, but we'll get there when we get there. So your types of data models. We start at the top, the most conceptual, aptly named the conceptual model. This is a high-level outline of what your data model eventually might look like. This is probably with non-technical people, stakeholders, maybe a couple members of your team, users, things that you expect will give you the shape of what you want your data to look like and how you might need to use it. Once you have this idea, this plain English conversation about the data that you're going to use, then you get into your logical model. Your logical model is something that you've probably seen before. It is a blend of concept and execution. It is a diagram of the data that you're going to use and the relationships that you're expecting. Sometimes it's called a domain model. It is one step removed from your physical model. The physical model is exact to you. No two physical models will be alike. This is how your data is going to work for your system using the specific technologies that you chose for this task. Let's step one back to the logical model. Here are two examples of notation. This one on the right, specifically an entity relationship diagram. Let's have a look at this one on the left. This gives you a good sense of what kind of data you're going to be using and what you're going to use it for, right? But it doesn't tell you some of the details you might need when you're actually looking at your functionality. For example, here we see that college has a relationship with affiliation. How many can it have? We don't know. Is it limited to one? Can it have many? You can expect that a student might have one age, for example, but can the student only enroll in one college? We don't know from this model. On the other hand, here, this entity relationship diagram shows us specifically what the relationships between our data will be, using this notation here to connect these tables. Does anybody know what this notation is called? What was that, please, in the front?
Crow's foot.
He's exactly right. Crow's foot notation. Very good. Crow's foot notation is also called Martin notation. It uses these symbols to help you understand the relationships between your data. You see here, this is a one-to-one relationship with these lines. The circles show whether something is optional, and the crow's foot shows a multiple relationship. So with those three keys, you can understand what each of these is. This allows for many. This allows one, but maybe zero, because it's optional. This allows for many, but maybe zero, because it's optional. Let's look at that in practice. Here, you can refer to our little chart here. Can anyone tell me, for example, what the relationship is between students and ID cards? Yes, in the front.
1-to-1.
How do you know?
Because one student should have one ID card.
Right? Doesn't that make sense? It's something that you would know to be true, but with this diagram, you can take it to anyone, any part of your business, and show them this model and hope they would understand that this is what you're going to be expecting as you're using this data. So now let's move on to normalization and denormalization. It's all well and good to be able to represent your data in a model, but is your data any good? Database normalization usually follows Code's normal forms. Code was a guy from the 70s. There are 6 normal forms, and some of them have some subheadings, but we'll talk about 6. Your data is considered normalized approximately when it hits the 3rd normal form. But what does any of that mean? Look at table 1 here. You'll notice here that in the student phone area for row 1, there are 2 numbers. The first rule of normalization says that is not allowed. You cannot have 2 data points in the same cell. So we've normalized it here, and now you can see that there is 1 row each for each of the relevant points of data. You'll still see quite a bit of redundancy in this table. That's because we're only at form 1. Denormalization is the process of taking a normalized database and deliberately reintroducing redundancy in order to better achieve your business goals. Let's be clear that a denormalized database is not the same as an unnormalized database. An unnormalized database is one that you have not yet cleaned up. A denormalized database is one that you have tactically reintroduced redundancy into to achieve a specific end. Think about a bookseller. Let's say you're using a SQL database to run your small independent bookstore. You have a couple hundred books, and you also have your inventory. Each of those books has a price. You need to know on each given day how many books you have and what they currently cost. Every time a customer comes to the register, you do not want to have to run a join on your database to find out what the book is and what it costs. So perhaps each morning you run 1 query to get all of your inventory list, right? Your books and their prices, and you save that to your database. You now have redundancy because in your joined table, you have information that is saved in other places in your database, but you can read that 1 table faster for every transaction every day. Slightly redundant in the database, denormalized for optimal use in your use case. So, what did we learn? Who can tell me what is data modeling? Don't be shy. What do we got? All right, fair enough. Database modeling. Database modeling is the practice of representing the data that you have and the relationships that exist between them. What kinds of data models exist? There's 3. Can anybody give me 1? Logical. Physical. What is the most abstract one? The most conceptual. Being carried by the front row here, folks. All right. And what about normalization and denormalization? Let's start with, what is the practice of normalization? Yes?
Reducing redundancy in your data.
Excellent. And denormalization? Yes.
Deliberately reintroducing redundancy. Deliberately introducing redundancy.
Very good.
Depending on your use case.
Very good, yes. As we know, let's say again, a denormalized database, not an unnormalized database. So, thank you for your time today. Here are some resources you can use to learn more about this. I know we just did an introduction, and if you'd like to speak to me, here are some resources you can use to do that.